Meet the next generation electrosurgical analyzer, the Fluke Biomedical QA-ES3. This all-in-one analyzer offers improved functionality, accuracy, and ease of use over its predecessor, the QA-ES2. The QA-ES3 collects all measurements including vessel sealing, high-frequency HF leakage, contact quality monitor, and output power distribution in single or continuous mode. It also measures cut and coag waveforms with either monopolar or bipolar outputs. The automatic power distribution feature allows automatic measurement of power, current, peak-to-peak voltage, closed load only, and crest factor. The addition of automation speeds up testing and helps reduce human error. At first glance, you'll notice the QA-ES3 has been redesigned to reduce the number of connections. All of the multi-purpose ports are accessible from the front, along with function keys and a selection knob. The large LCD screen is easy to read, and on-screen guides are designed to guide you through testing. When you pick up the QA-ES3, you'll quickly discover it's lighter than the previous version, 5.5 pounds lighter. Everything you need to test all critical functions of today's high-power electrosurgical units is either integrated into the design or included with the unit. There's no need for extra cables, leads, or switch boxes to test precision power, current, frequency, crest factor, and load resistance ranges. The state-of-the-art technology, the QA-ES3, provides exceptional accuracy and range of measurement. Its wide range of loads allows users to test the breadth of electrosurgical generators. Notably, the QA-ES3 has a 20-ohm load to support Valley Lab electrosurgical units, including the Force Triad. The QA-ES3 also has double the RMS current range of its predecessor. It can measure current from 0 to 5,500 milliamps. Plus, it's twice as accurate with current accuracy, 2.5% of reading, plus 1 milliamp for all loads. It's exceptionally accurate with generator output power accuracy of 5% greater than 10 watts and 5% plus 1 watt otherwise. In addition, it provides a load resistance accuracy of 2.5%. The QA-ES3 is also highly precise with a 1/10 of a watt resolution up to 99.9 watts and 1 watt above 100 watts for power measurement. Featuring a universal power supply and in compliance with global standards for testing electrosurgical devices, including IEC and ANSI/AAMI, the QA-ES3 can be used worldwide. It can store up to 5,000 records, making it convenient to store results and retrieve later. Also contributing to the QA-ES3's reduced test times is its Bluetooth wireless capabilities, which makes it possible to quickly and conveniently transfer results to a PC. The addition of Answer software further automates and standardizes testing, speeding up overall test times and minimizing human error. Answer software can produce a single electronic test report, which displays all preventative maintenance tasks, including visual inspection, electrical safety, and performance characteristics. The QA-ES3 is an all-in-one analyzer to get the job done accurately and quickly. With industry-leading specs, the QA-ES3 can test all modern high-power electrosurgical units.
Hi, my name is Sławian Angelov and I'm biomedical equipment technician. The IDA5 is really accurate and fast. We use Hospira infusion pumps. Before we used the IDA5, we didn't have any idea what is the percentage of error. And now with the analyzer, it's way easier to find the exact numbers. You can precisely see what is the volume, what is the flow, and what is the pressure. And then you know if the pump works right or not. You can hook up 4 pumps in the same time. The IDA5, it just does the job I think people will be really surprised to find how easier their job can be once they use it. You have two different versions. The IDEA 5 is more for like working on your bench. It's not as easy to transport, but you have a lighter version for that. IDEA 1S, it's very light and it's portable. You can transfer it like very easy to different places. We have a biomed in our department that goes to different clinics. He has to travel there. He's so excited because he can just take it, do his measurements, come back. It's simple as that. You have a touch screen. It's really easy to navigate. Being a biomed, you always have to go really fast. So equipment like that helps you in a big way. I always think Fluke Biomedical, they move with technology. And these days, technology goes so fast. It's probably the most advanced infusion pump equipment that I used so far in my career. It makes your job way easier. I love it.
Patient monitor testing can be quicker and easier than ever before with ProSim 8 from Fluke Biomedical. We're going to do a patient monitor test, and we're going to try and do a complete but quick test of this patient monitor. The parameters we're going to test are ECG rate, respiratory rate, invasive blood pressure, channel 1. We're going to do a cuff blood pressure and IBP measurement and oximetry. We're going to try and get all of this testing done in under 5 minutes. As you can see, there's a digital clock shown in the lower left-hand corner of the patient monitor display. So you can be your own judge as to whether we can get through this test within 5 minutes or not. So as I begin the test, we are already connected to the device under test. All of the connections have been made ahead of time, including the NIBP cuff. And we are going to zero our invasive blood pressure transducers on the patient monitor at the very first step of what we do, followed by a selection of a simulation of all coordinated patient parameters. We'll do hypertensive first, followed by normal, followed by hypotensive, in order to assess whether we have a performing patient monitor. We will compare the displayed values on the ProSim 8 against what's displayed on the patient monitor at each set of simulated parameters. Are you ready? Let's begin now. First thing I'm going to do is 0 P1. It is at 0. And now what I'm going to do is pick hypertensive. And the simulation will already begin, so I'm going to start a blood pressure, cuff blood pressure reading. In this case, we're looking for an ECG rate of 130 beats per minute, respiratory rate of 40. We're looking for an invasive blood pressure display of 200 over 150. We're looking for NIBP of 200 over 150 with a mean of 167, and an SpO2 reading of 90. And it looks to me like we've got all of those on the patient monitor. 130, invasive blood pressure 198 over 149 with a mean of 167, and we have 90 O2 sat and 197 over 142 with a mean of 165 on the cuff. Let's move to normal. The normal simulation includes heart rate, ECG rate of 60 beats per minute, a respiratory rate of 20 breaths per minute, invasive blood pressure of 120 over 80, a cuff blood pressure of 120 over 80 with a mean of 93, and SpO2 at 100% O2 sat. As you can see, the patient monitor is already displaying 60 beats per minute for heart rate. It's gotten 119 over 79 with a mean of 93 for invasive blood pressure. And the cuff is making its measurement now for the O2 sat, or for the NIBP reading. O2 sat is 100%. There we go, 121 over 77 versus 120 over 80, pretty good. We'll go to hypotensive now and start another cuff measurement. We're looking for an ECG rate of 40 beats per minute, respiratory rate of 15 breaths per minute, and invasive blood pressure measurement of 50 over 20, and cuff blood pressure of 50 over 20 with a mean of 30, and an O2 sat of 97%. You can see that the ECG rate on the monitor is already 40. Our invasive blood pressure is 50 over 19, very close to 50 over 20. Our cuff is working on getting its measurement, and the O2 sat is 97, right on with what we asked for, what we're simulating. We started at 18:55 and 44 or 45 seconds, and we're going to finish very shortly here. Done. And we have good values. As you can see, it is possible to do a complete, quick assessment of patient monitor performance using ProSim 8 and front panel controls in under 5 minutes.
The first step is to select the appropriate size cuff. A properly sized cuff should span approximately 2/3 of the distance between the elbow and the shoulder and wrap around the limb. Use of an improperly sized cuff can result in inaccurate blood pressure readings. Connect the cuff to the tubing and the tubing to the monitor. Press the NBP button on the front of the monitor to initiate a blood pressure measurement. Following deflation, the NBP measurement is displayed on the screen as systolic over diastolic, with the mean arterial pressure in parentheses. This is the time the last measurement was taken. There are 3 different NBP modes: manual, automatic, and stat. To change the measurement mode, highlight and select the NBP numeric pane. Choose the desired interval time. The blood pressure measurement interval displays here on the screen. Use the NBP menu to make other adjustments, such as initial inflation pressure or alarm limits. On some models, you can also use this menu to enable invasive blood pressure monitoring.
Introducing the ProSim Spotlight SpO2 functional tester, the newest member of the ProSim family. The scenario that we're going to talk about today is one that happens every day in the medical facility or hospital, where you get a call from the clinical unit. The oximeter is not working on some medical device. So you grab your Spotlight and you go up to the clinical unit. In this case, we find the device turned on. It's a defibrillator. And we will turn on our Spotlight SpO2 functional tester. Wait for it to go through its self-check. And we will then connect the oximeter sensor from the medical device, and we'll watch this bar down at the bottom. It's called the signal strength bar, and you can see that it has a good signal, and you will begin to see the display on the screen of the defibrillator. Now, testing this functionally really quickly is just a 4-button push. We're going to go to our custom setup and go to custom 3, which is programmed for a patient with a high heart rate and a high O2 sat. You can see it sets off the high limit alarms, which is exactly what we want it to do. We'll watch till the oximeter reading and the heart rate settle. And then we'll move to custom 2, which is a normal patient. We want to let the alarms continue to sound because the normal conditions will let them silence on their own, an important part of the functional test. Again, waiting for those to settle, and then we'll simply push one more time for our hypotensive patient with a low O2 saturation, low perfusion, and you'll see the alarms will sound again, this time on the low end. And again, we'll wait for the readings to settle. And we'll push one more time to get back to a more normal reading so the alarms will quiet once more. And there we are. You've tested 90% of it in right around 30 seconds. The SpO2 functional tester, Spotlight, the newest member of the ProSim family.
Talk to you about the Impulse 7000 defibrillator and pacemaker analyzer from Fluke Biomedical today. This is the Impulse 7000. You can see we have it all set up. We even have some ECG leads connected to it. This unit is designed for testing any defibrillator, including AEDs, and the transcutaneous temporary pacemakers that are integrated into defibrillators. So as you can see here, we have it set up with the plates for if you're going to use paddles. They just go right on the plates just like that for you to control the defib and deliver the energy. Or we can remove the plates and we can connect the quick combo leads, the adapters you can get right from Fluke Biomedical. So you can just order those, and they just connect up nicely, and those are really hands off, so you don't have to worry about any energy mishaps. So if we want to talk about the ECG connection posts up here, these are designed for up to 10 ECG leads, which gives us a 12-lead ECG signal, and they're really secure and easy to connect your ECG lead wires to, no problem there. So how do we select up what we want to do? You can see on screen it says select a function. In other words, tell me what to do. So we would follow the function keys on this side of the screen. And so let's start with defib. Now you can see here that once we have selected defib as the category that we want to test, now we have different kinds of tests that we can do. Energy, synchronization time, charge time tests, and we can select a load. If we have the 7010 external load accessory, we could select our load there. Otherwise, as you see here, we're selecting the internal 50 ohm load. All right, so let's pick the defib energy. So we can send a waveform if we want to, but you can see that the Impulse 7000 is actually ready to deliver energy right now. So we just charge up our defibrillator. And we have 20 joules selected, deliver our energy. And you can see that we immediately get not only the energy level displayed on the screen, but we get the wave pattern. So in this case, it's monophasic. I did not have to tell Impulse 7000 what to look for. It told me what it measured and what it saw based on the energy delivery. So that's kind of important. It tells you what it sees. If it was a more modern defibrillator, it would, or a AED, it would have shown us biphasic. One of the things that's important when we do defib energy tests is to actually visualize, to be able to see that wave pattern. And so on the back of this unit, back over here, are the oscilloscope output that we can use to actually see what that wave pattern was. We also have a delayed ECG output, so we can see the ECG signal that we're actually delivering to the defib. And we have the USB port where we can control this from software on a computer. So that's defib energy testing. We'll go back. And now let's pick the pacer. So this is going to test transcutaneous external pacemakers that are integrated into the defibrillator. You can see that we have the kind of pacer, the ability to select that. So we want to select Zoll because that is the pacer that we have connected to it. Now, if we just leave it on the defib energy inputs here, the problem with that is though 50 ohms is not necessarily the appropriate load for every brand and model. So the best way to do this is to move our connections from the 50 ohm load and connect them over here on the pacer inputs. And now when we've selected the brand, we have already selected internally to the Impulse 7000 the load appropriate for that brand. We want to also tell the Impulse 7000 that we're using the pacer posts, and then we want to pick done. Now we're ready to receive energy from the pacemaker, as you can see that we're doing right here. So these are all of the pacer parameters that we would do, and you will always do a pacer parameter test. In addition to those tests, you will have other tests that are required not only by the international standards, but also may be required by the manufacturer. And those would be asynchronous tests or demand mode tests, and there are a few more tests depending on what it is that the manufacturer requires. All right, ECG. The ECG waveforms, these are simulated waveforms that are delivered through the lead wires, and they're also delivered through the pads or paddles connections. So we have a variety of different categories of wave shapes that can be displayed and sent to the patient monitor part of the defibrillator. And this is important when you're going to do AED testing. So you can select a whole lot of different arrhythmia waveforms here. We're not going to go into all of them right now. So at this point, you have had a quick introduction to the Impulse 7000. You've seen a test for patient pacer parameters, and you've seen a defib energy output test. We suggest that if you want to know more, you go to flukebiomedical.com, our website, and you can pick from the product drop-down, you can pick defibrillator analyzer and Impulse 7000. And the neat thing about that is you can ask for a quote if you're ready, or if you want to go try this out on your own, you can ask for a demo, and we'll make sure that
performing any of the actions depicted or described in this video. We've divided your ultrasound leakage test into 4 easy-to-follow steps. Step 1. Fill your soak tray. When filling your soak tray, use the same cleaning agent for cleaning the ultrasound probe. You can also use tap water. Step 2. Connect equipment. Start by plugging your transducer adapter into one of the 2 ports on the top of the ULT 2020. You can use either port. Next, plug the ultrasound transducer into the adapter. The adapter should click into place. Look in your ultrasound transducer manual for OEM recommendations on connecting your transducer. Once that is attached, plug your dual-prong conductivity probe into the second port on the top of the ULT 2020. You can use either port. Now all parts should be fully connected. This includes the ULT 2020, dual-prong conductivity probe, transducer adapter, and ultrasound transducer. Step 3. Insert probes into the soak tray. Start by placing your dual-prong conductivity probe on the edge of the soak tray. Ensure the tips are fully inserted into the cleaning solution. Next, place your ultrasound probe into the soak tray. Step 4. Turn on the ULT 2020. Press the button marked Power on the ULT 2020. The screen should light up. If not, check to ensure the tester either has batteries or is powered by an AC adapter. Once on, simply press Full Test to begin the test. The machine will do all the work. You just need to wait for the results. When finished, Pass or Fail will appear on the screen, indicating your results. If a printer is attached, the results will print off in detail along with a pass or fail. Repeat this process for all ultrasound transducers.